Hello, everybody, and welcome to um, today's webinar with partner webinar with SWAN and the Florida Water Environment Association, or FWEA. Today, we're going to be discussing digital solutions for water reuse. Thank you so much for joining us. We're really excited to have you, and we have two really exciting case study presentations. For those of you who don't know, I'm Maddie Zimmerman, SWAN's America's manager. And before we get into the presentations, we're going to give an overview of SWAN and FWEA for those who aren't familiar. This call will be 1 hour, and feel free as we go to put your questions into the chat. So first, a quick overview of SWAN. So we are a membership-based nonprofit, or also an industry association that's really about transforming water together. So we're all about smart water, digital water, intelligent water, whatever your preferred term is. And we want to bring everyone from idea to pipe. You can see the cross section of our members on the screen. So we bring everyone together into this collaborative platform. We aim to be both a place where you can find cutting edge knowledge around digital transformation, as well as being a collaborative platform to work with other members of the space to, again, help drive digital transformation and help make the water industry more efficient and resilient. And we do this through 5 different ways. First way is through our members. There's lots of ways to network with each other, whether that's utilities working together, utilities and solution providers, multiple solution providers working together. We are a platform to help you share your best practices and collaborate. We do research. We write white papers, create tools, which are all worked on by our members to help, again, move the sector forward. We have different regional alliances, such as the Americas Alliance, and different technical communities that focus on things like adaptive data management, digital twins, AI, smart metering, and energy efficiency. We showcase our members as thought leaders by showing their case studies and showcasing their best practices. And then finally, SWAN wouldn't be where it is without our volunteer leaders. So all of these different committees are all spearheaded by volunteer leaders. So it's a great way to really help move the sector forward and have a direct impact on the programming. And this is one example of the research projects that we talked about. We're currently working on agentic AI and looking at what its role is in the water sector. We currently have a call out for case studies now to learn about how utilities are starting to use agentic AI, and whether that's a full deployed project or just getting started. We want to hear about it. And so we're hoping to have this done by the end of the year. And finally, every year we do our annual conference. This year it'll be in Tampa, Florida from June 2nd to June 4th. And we really hope to have a really strong crowd from Florida. And the theme is adapting your digital journey. The first day will be interactive workshops, which include digital twins and AI, bridging the digital divide, which focuses on the challenge of small, rural, and under-resourced utilities, as well as a young professional workshop. The second day is high level, looking at strategic industry trends. And then the third day will track on water and wastewater. So we hope that you can join us in Tampa. It'll be a really fun event, and we're looking forward to seeing both our members and meeting new faces. And so with that, I'll pass it over. I'll put these links into the chat in case you want to learn more, but I'll also pass it over to Jen at FWEA.
Hi, everyone. I am Jen Neifeniger with Crollo Engineers, and I am the chair of FWEA's Emerging Water Technology Committee. So I just wanted to give a brief overview of FWEA. We've formed a partnership with SWAN to help develop and promote smart water networks and digital solutions for water utilities. And with their upcoming conference, SWAN conference in Tampa, this is a really nice opportunity to develop a partnership. So the Florida Water Environment Association is a WEF member association. It was started in 1941 and has more than 1,300 water professionals today. My goal today is I just wanted to introduce you to FWEA and our emerging water technology, including ways to get involved and upcoming events and ways to get involved, whether you're in Florida or not. So the vision of FWEA is dedicated to promoting a clean, sustainable water environment by supporting and uniting our members with the public through public awareness and outreach, providing professional development and networking opportunities, and creating alliances to promote sound science-based public policy. So our strategic goals include member engagement through training, education, and networking, public awareness and outreach for educating the public at all levels, alliances to inform water professionals on sound science-based public policy, and workforce development and professional development. So FWEA has more than 20 committees. The Emerging Water Technology Committee is just one of those. The vision of our committee is to explore emerging technologies and innovative approaches to support the advancement of cutting-edge solutions to address Florida's evolving water challenges. So with that, if you have an innovative technology or process that you would like to share with us, please contact me. We have a monthly committee meeting where we invite people in to share a technology or innovative highlight. Also, if you're interested in joining the committee, you can fill out a volunteer interest form at fwea.org/committees. So upcoming, we have the Florida Water Resources Conference in April, where our committee will be doing a Sunday workshop from benchmarking to intelligence using data analytics and AI to enhance utility performance. We also will have a committee meeting on the Monday, April 27th at that conference as well. So finally, we'll just put my contact information up on the screen. Feel free to contact me directly or to go to fwea.org to volunteer or sponsor a committee. So thank you. So with that, we will move into our case studies. So first, I will be introducing Suzanne Meckler, who is one of our fellow FWEA members. She has more than 23 years of experience as an environmental and civil engineer for CDM Smith, focusing on all things water. Since she joined CDM in 2002, she served as a project manager, engineer, and client manager overseeing projects in the South Florida area. She's currently the principal in charge of the Progressive Design Build project for Palm Beach County Green Cay Phase 2 project. This project provides indirect potable reuse to replenish the aquifer while also providing an educational center and a park. She holds a master's from the University of Florida. Go Gators. She was born and raised in Palm Beach County, and she enjoys spending time kayaking, boating, paddleboard. Sounds like all things outdoors with her husband and 13-year-old son. So Suzanne, take it away.
Thank you very much. Can you guys hear me okay?
Yep, we hear you great.
Excellent. Thank you. Well, as past president of FWEA, I'm really, really proud of this committee. I think that you are, Jennifer, are doing some amazing things, and the collaboration that you've had with SWAN is impressive. And really, the intent of the organization is to think outside the box, and this committee is definitely helping that. So appreciate the work that everyone's doing, and I'm proud to be presenting today. So I'm just going to do a case study. Mine's going to, some of you probably are familiar with this project. I'm going to try to take a little bit of a different angle. I'm going to focus on permitting and implementation, but with a digital connection. I know Michael is going to focus on a lot of piloting and the great work that they're doing out there. So we'll try to make it a little bit different for you guys. So next slide. Palm Beach County Water Utilities Department is really, innovative in what they've been doing. I mean, we're here to implement the project, but they've initiated this project over the years, and it's really a continuation of some of the great work that they've done. They're a huge believer in water supply management and aquifer recharge. The other projects that they've previously done include wetlands that are already there utilizing reclaimed water. So they've been a leader in reuse innovation for years. These are highly visited parks and facilities, so very much recognized in the community as environmental stewards. And this project, the additional add-on that they wanted to focus on was education and outreach. I know that's not really the digital spin, but it really is going to be critical in capturing that next generation. So I did want to highlight it. Next slide. Just to give you a little bit of background and set the stage, this is their Southern Region Water Reclamation Facility. This is where our facility is going to be taking water from and treating it to the next stage, next level. They are domestic wastewater and really no industrial wastewater. And you're going to see how important that is later on in the discussion, and really related to permitting. That helps them set the stage a little bit of making this system work very successfully. Their treatment process is currently 35 MGD, conventional activated sludge, and they obviously do, like I said, have reuse currently operating, just like most facilities in South Florida. Next slide. So the facility, Southern Region, like I just mentioned, is in purple. The Green Cay wetlands and there's another wetlands over here that I have not highlighted called Wakota-Hatchie wetlands, but those are all existing, and they've been existing for over 20 years now, maybe 25. They've been using reclaimed water to discharge their created wetlands, raised boardwalks, huge birding locations, and very successful in the community. Next slide. So this project is really going to is going to leverage the reuse to a higher quality level that allows more interaction, close interaction with the population, right? So it's still officially indirect potable reuse as defined by the rules. It is treated to drinking water quality and then stabilized for the lake system. So the Green Cay Park is being created using an existing farmland that Mr. Winsberg, who is an amazing person, is about 90 something years old now. He decided that he wanted to work with the county to utilize this land for public good, and not sell the development and other things. So he was a key player in this. You can see how important the location of this facility is for a really successful indirect potable reuse project. It's, you know, we do have to get it from the water purification facility to the park, but then we are able to put wells on the site, and those wells are relatively close to the water treatment plant. So it really connects good with the system. And like I said, even though it's not a direct system, the indirect and really aquifer recharge is critical for them. Next slide. All right, so technology is ultrafiltration, reverse osmosis, ultraviolet advanced oxidation, basically your typical standard full advanced treatment technology. Overall, the project is a $100 million progressive design build. So CDM Smith is designing and constructing it. It's a 2 MGD facility. It will be in operation as a 2 MGD, but it has the ability to go to 4 MGD. The entire facility is built out for 4. And really one of the key components that I'll talk about is the compliance with the new Florida regulations. I know California's had regulations for a couple of years. We're only about a little bit over a year into our new regulations. So there was a lot of planning associated with that. Next slide. I'm not going to talk a lot about the other components of the project, but I just really wanted to highlight them so everybody was aware of what this project does entail. The right picture, top right, is the education center co-joined with the water purification process area. So the box in the back is a water purification process, that 2 MGD expandable to 4. But really, the rest of the facility is education, including classrooms. So this is really critical, and hopefully the intent, and JEA is doing something similar, is to really get the next generation to believe in this, to understand the technology, to support it. So you see on the left, there's an exhibit that we are creating to get kids to have gaming opportunities that have water supply impacts, things like that. So we are incorporating a lot of digital components in throughout the education facility, because obviously that's what kids are used to anyway. And then the bottom is some of the graphics of the park. So a little bit of everything is part of this project. Next slide. Okay, so I tried to organize this a little bit to talk to this group about how you can connect digital to reuse. And I'm going to go through a couple of things that I think are the connectivity that everybody should be considering. So one of the things that we had to do, and this is required for all new projects under the new permits in Florida, is the source water characterization and evaluation. And this is critical because you need this, which is the new requirements, to get approved prior to doing any project. And this really sets the stage of what you need to do differently than you've been currently doing as far as tracking data and understanding the data and understanding your sources. And this is an area that I really think that can be leveraged for digital analysis and use in the future, because we do see gaps in the current information that is used in your typical industrial pretreatment programs. So this data has been used for the pilot studies. Pilot studies are obviously dependent on making sure you're actually piloting to your source water. So a lot of that connectivity is critical. Next slide. Another area, and this was something we did during the pilot, is really thinking outside the box in how we are able to leverage the data. So as part of our pilot, and we had a full-scale pilot, meaning we had all 3 treatment units connected, we got approved for a Water Research Foundation paper. It's WRF 5209, which evaluated giving membrane the virus removal credit using rapid in-field molecular-based methods. Our team did a paper. It's out there. I think it was actually February 2023 was in an article. The key here is that we are going to be making real-time decisions in reuse, and to make sure that the public is protected, that real-time information and rapid results is really important to prove to the community the success of what you're doing, and also manage issues as they arise. So these new ways of evaluating and capturing the data in the field and making it more real time and rapid, especially at this virus level, is going to be key. And I think it's something that all of our projects should be considering. Next slide. All right, I'll try to go into the permitting a little bit. Really, this is we're following JEA as far as the process, so we'll leverage all the things we learned from them. We'll likely be the second one permitted, but we, similar to JEA, we did all the design originally under the old permit, and we did have to work with DEP to really make sure that our piloting, our design, and everything would work under the new rules. And this really is a focus on, the pathogen requirements, redundancy in the treatment trains, also the UV system, which is a really complicated system and has a lot of data associated with it, making sure we met all the requirements for that. So from a permitting status, Palm Beach County is currently in the process of getting the enhanced pretreatment program requirement and ordinances approved. Once that happens, we will submit for a permit. So that will be the next step. Next slide. Some details that I want to highlight regarding the permit is and maybe a little bit of the differences and the considerations for each reuse project. We are discharging to a surface water. And so because of that, under the old regulations or our current permit, we're defined as a Class 3 limited surface water. But we created these lakes. They're not existing lakes. So we have been working with DEP on the ability to get a variance in the pH. That allows us to get a little bit more flexibility in management of the surface water system. We want a stabilized system. And we also have to do toxicity testing. So this is another area that there is a lot of benefit in leveraging some of your water quality and digital information so that you can defend and make sure that there is a clear expectation on what your discharge will look like, how you can stabilize that water body. So that you'll see later that that's part of our process of what we're trying to do. We do have to follow all the typical requirements for the 2 separate treatment processes, the log reduction and things like that. And that is, our process is currently in compliance with all that. Next slide. All right, I'm going to just give this to you because I feel like anytime you do reuse, you have to kind of explain the process a little bit. And this discussion is mainly to highlight the data and the benefit of the data and how much is going to be used to support operations. So the presence of free chlorine residual at the end of a breakpoint chlorination. So you can see here, I have the UFRO and UVAOP, but for our purposes and very specific to our plant, we added this breakpoint chlorination. And that's really the presence of the chlorine residual at the end will be used to monitor and control the process and maybe used to obtain the log credit removal for viruses. So we're trying to do some connectivity there. A free chlorine residual of about greater than 0.2 as chlorine contact time of 15 minutes. So basically there's a big pipe that goes underground that's maintaining this. And that's to help with that virus removal and the log. I think we're obtaining 6 log with that effort. So it's not effective at eliminating ammonia nitrogen. So we are injecting sodium hydroxide to increase the pH to 7.5. And like I said, we want a variance to allow us a little bit of flexibility in the management of that. But really the UVAOP after that process is all the stabilization. And this stabilization is not something you would normally need for any direct potable system, but it is something we're going to need for our lake system. So I just want to make that clear, which is why every reuse project is different. Next slide. Okay, so the reason why I gave that diagram earlier is so I could throw this up and not overwhelm you guys. But, this is the screen for our, it's in black and white right now, but this is our draft HMI screen for the treatment process. And as you can see, there's going to be a ton of information on here. There's going to be a lot of monitoring going on. We have 4 or 5 separate chemical treatment systems or chemical systems. So the data is critical in this instance, and we are working now and we're in construction, really trying to connect the dots and make sure that all the data that we're collecting is really being utilized and how it can be utilized to the best of its, use, right? Next slide. The other thing that we're currently evaluating is during the startup and commissioning, which we have ongoing plans to do that with startup and commissioning starting in the summer. It's a incredibly detailed effort on a plant like this, as I'm sure anybody who's done a reuse plant is familiar. And all of this information is really going to end up being in a digital format in some form or fashion. A lot of it is related to SOPs and training. And I think that the trend that we all are seeing is that we really need to leverage the information and not put books on shelves, but really figure out how to incorporate it in the daily lives of an operator and make their life easier, but also give them more information to make better decisions. And so this is all part of the process of what's going to be done and hoping that really that can transition into leverage of this data. Next slide. So this is, that's all I have on the Green K project, and I'm going to go through a couple of other high-level things. So I did want to, before I left this project, give you guys a QR code. This gives you access to the Palm Beach County's website and any updates on the project. And this is my vision of what that park will look like eventually, and I'll be kayaking in it, but not today. We're still in construction. We're close, though. Next slide. I wanted to end my talk to just go through a little bit of the connectivity. And this is really based on my experience with Green K. I do think there is a huge connectivity between reuse and digital. So I'm going to highlight some of the things and areas where I can see that. First of all, and I talked about this, utilizing R&D to support, the wastewater data tools, right? We are going to see a huge ramp up in the amount of reuse projects, and also that means a huge ramp up in data collection as well as identifying mechanisms to get buy-in from the public. And this R&D is really important to make sure that we look at those methods, we vet those methods, and then we figure out how best to use them. Another way is to really understand where the risks are coming from, and DEP's effort in this enhanced pretreatment program is really a start of that, and that can then be leveraged. Knowing better where all your source water is coming from can better help you manage the back end, and really identifying the risks and tagging them and using data to do that. With that, you can then start doing statistical models and then help correlate it so that you don't, you know when you're going to get spikes and things like that, and you can better help be predictive in resolving those issues. Data visualizations that we've talked about is going to be key, especially for all this information. The compliance with SCADA, GIS, the spreadsheets that every plant has. Really, the next stage is getting that at your fingertips, right? So it's connected and very easy to utilize. So you can go to the next slide. I'm not going to go through each one of these individually, but I've summarized them in this kind of like 8-item thing. Really tracking the pathogens, tracking the bacteria, being able to tell the community that where these things are and where they're getting destroyed, how you're resolving it. There's got to be a confidence level. Monitoring multiple locations and facilities, and that can include your wastewater plant, it can include your reuse plant, it can include your indirect potable reuse, include your water, any connectivity between the two, really having a holistic view. The visualizations, like I said, helps that. And then the last slide, if you don't mind, just hits on a couple of other projects that I think everybody should look at in Florida. This is a Pure Alta project, and these are the websites here so you can get access to them. And the H2O purification facility project. Both of these projects are also incorporating digital tools. I know that Pure Alta has like a living lab that they're working on. And then JEA has a ton of interactive public education information, but they're also doing a lot with their SCADA and remote system monitoring. So I really think that we all are working together and also can learn from each other. So I would encourage everybody to look into those projects as well. And please feel free to reach out with any questions. That's all I got.
Thank you so much. What a
Thank you.
great project. Yeah, so I would encourage everyone, go ahead and if you have any questions, post those in the Q&A section, and we'll invite our speakers to come up at the end and we'll go through any questions at that time. So for our second case study, I would like to introduce Michael Lutz. He's an engineering associate with Los Angeles Department of Water and Power, contributing to major water infrastructure and sustainability initiatives across the city. He holds a Bachelor of Arts in Rhetoric from the UC Berkeley and a Master of Science in Civil and Environmental Engineering from UCLA. At LADWP, he supports Headworks DPR pilot and the LA Groundwater Replenishment Project, applying his interdisciplinary background to advance safe, reliable, and innovative water solutions for LA. Thank you, Michael. Take it away. You're on mute still.
Good morning, everybody, or good afternoon, I suppose, depending on where in the world you are. Thank you for the great introduction. My name is Michael Lutz, and I work for the Los Angeles Department of Water and Power and for the Recycled Water Group. And today, we'll talk about how digital solutions can empower new applications in the water industry, specifically in direct potable reuse. Next slide, please. So Los Angeles has historically gotten its water from 3 main sources. The historical imports consist of the Los Angeles Aqueduct coming from the Eastern Sierras, and that consists of about 41% of Los Angeles water. Historical imported purchases from the Northern Sierras or from the Colorado River is about 50% of our water. And then the other 9% consists of our local supplies, including groundwater, recycled water, stormwater, and conservation. So these sources are challenged by climate uncertainty, drought, and seismic activity. These aqueducts cross major fault lines. And so it's not a matter of if, but when we get that big earthquake that can majorly disrupt our water supply. Next slide, please. And so recycled water is a really critical part of the picture here for Los Angeles. We've been supplying non-potable recycled water for over 50 years. And through our 4 treatment plants, wastewater treatment plants, and 70 miles of purple pipe. More recently, we are currently in construction of the Donald C. Tillman Los Angeles Groundwater Reclamation Plant program, and that is a $1 billion project, and it'll begin delivering water for aquifer recharge by 2028. And then looking towards the future, we are going to implement a direct potable reuse program. Now, the difference between indirect and direct is that there's no environmental buffer. And so the treatment requirements are a lot higher, and so are the monitoring requirements. Next slide, please. So the objectives of our demonstration facility, this is still in the planning phase, but it'll pave the way for all the future direct potable reuse projects, such as Pure Water Los Angeles. So to make that possible, the demonstration facility will help to develop our workforce, research, public outreach, and engage with regulators. Next slide, please. Now, we currently have a 50 gallon per minute DPR pilot. We've been operating for about 6 months, and we are comparing effectiveness of the baseline treatment in the California regulations with some alternative treatment trains. Next slide, please. So this is just a high level of the California DPR regulations. These are under the Title 22, and they were adopted in October of 2024. And they provide a comprehensive statewide framework for direct potable reuse. So there's 2 main treatment elements to the regulation. There's chemicals and pathogens. For the chemicals, we need 3 distinct removal mechanisms and at least 3 treatment processes. So there's a mandatory order of those processes: ozone, followed by biological activated carbon, followed by reverse osmosis and advanced oxidation. And that order is fixed and you can't move it around. And then moving towards the pathogens, there are 3 distinct pathogen removal mechanisms that you need. 4 processes, each one must be greater than 1 log reduction value, and no process can be given more than 6 log reduction value, and that's so that you don't overly rely on a single treatment process. And for the design targets, we need to reach 20 LRV for viruses, 14 for Giardia, and 15 for Cryptosporidium. Now, for those who are not familiar with that terminology for log reduction value, let's say that we were to start with 100 units of a contaminant, and our treatment process can remove 90 of those, and so you're left with 10. That would be considered 1 log reduction value. If another treatment process reduces it by 99%, leaving 1 unit in the effluent, that would be 2 log reduction value. And so you can see how stringent are the design targets. So 20 log reduction value is 99.99 followed by 18 more 9s. And so the challenge is to demonstrate that we're able to achieve that level of treatment. So the design targets, they ensure that the system has redundancy and multiple barriers, and that ensures the safety of the treated water. And so without that extra barrier of the environmental buffer from IPR, we need additional treatment technologies. So the challenge is, how can we accurately measure that level of removal? Are we able to measure concentrations that low? And if not, how are we able to prove that we're getting those log reduction values? Next slide, please. So this is the 5 layers of the SWAN framework, and I just really liked how this gives you a nice way to think about the different elements of data and digital technologies. So the first one is in physical treatment, followed by online monitoring and sensing, followed by collection, communication, data management and display, and data fusion and analysis. So for our pilot, we're really focusing on the treatment processes, the physical treatment, and the online monitoring and sensing. Next slide, please. So here you can see the treatment trains for our pilot. And so the train 2 is the baseline treatment train in the regulations. We have ozone, followed by biological activated carbon, ultrafiltration, reverse osmosis, UV AOP, and then free chlorine. In our alternative trains, train 1A and 1B, we remove the ozone BAC and we add some additional post-reverse osmosis processes, including air stripping and GAC. So across each of these processes, we have numerous sensors: pressure, flow, temperature, pH, chlorine residual analyzers. And so we're collecting tons of data in order to evaluate these two processes. And we're also collecting a lot of grab samples that we send to our laboratories. And I saw a couple of members of our Los Angeles Department of Water and Power water quality laboratory here in the meeting. So great to have you guys here today. They've been supporting our pilot project, and they've been taking a lot of our samples and analyzing them. All right, next slide, please. So this chart shows the gap between what the research shows that our treatment processes can achieve and what we're actually getting credit for. So the limiting factor in each case is monitoring. For DPR, you need continuous monitoring to prove that the treatment efficacy of each process. For ultrafiltration, for crypto and Giardia, we get 4 log reduction values through pressure decay testing. And if there's ways to improve that pressure decay testing that can give us more LRVs. For virus removal, we know that the ultrafiltration can remove viruses, but currently there's no way to show or prove that that's approved by regulators. So there's opportunity there to increase. And finally, for reverse osmosis, this is one of the most effective treatment processes. However, it receives only 1 or 2 log reduction values currently. And so there's definitely opportunity to increase that. And so that's what we'll focus on for the rest of the slides here. Next slide, please. So conductivity is the baseline way that we measure the effectiveness of reverse osmosis. It's able to detect dissolved salts and ions, and but it's only able to give us 1 log reduction value. It's a really simple technology. It's reliable and effective. It's easy to maintain and operate, inexpensive. And so this is what everybody uses to obtain 1 log reduction value. Next slide, please. Now, the next level to achieve 2 log reduction values is the Sievers M9 unit. That's able to detect total organic carbon in the low parts per billion range. So there's no the downsides is that there's no competitors or even laboratory methods that we can use to verify the performance. It's very expensive, between $40,000 and $50,000, but it is an effective and field-tested technology. But for even in the application of DPR, although it's been done for IPR, additional validation studies may be required. So again, there's a lot of cost and technical barriers for implementation. Next slide, please. And then finally, we'll cover one of the emerging technologies for monitoring in reverse osmosis. It's sulfate rejection, and it can detect sulfate in the low parts per billion range. Sulfate is a divalent negative ion, and viruses are also negatively charged, so it's a good surrogate. And so the downside of this technology is that it's extremely expensive. It costs over $50,000 per unit. This has not been implemented yet in water reuse. So it's a promising technology, but a lot of work will be required to get regulatory approval. So we actually do have one of these units at our pilot, And we plan to test it out in our next phase of testing. Next slide, please. So I'm just going to talk about a few of the other requirements for direct potable reuse in which digital technologies are essential. And these are non-treatment barriers. And so early detection and time to respond is really critical. Placing sensors in the sewer collection system, we're able to detect unusual contamination before it reaches the plant. And then alerts are triggered if the readings go out of range, and then that gives operators the opportunity to respond. In addition to that, we have break tanks and storage tanks and reservoirs between the treatment and the distribution systems. So that gives another buffer. So if something goes out of range, the operators have an opportunity to react. They can divert the water, or they can take other measures to treat the water so that we make sure to deliver safe water for our consumers. Next slide, please. So in addition to that, there's additional operational safeguards. So there's something called a critical control point. It's built into the DPR regulations, in fact. This is something that's been used in the food industry for food safety. So what you do is you identify specific points in the process where the failure would result in the compromised quality. As soon as a reading crosses that threshold, there's an automatic response. So it could either divert the treatment process or take other measures, and it's automatic. So another way to prevent unsafe water from reaching consumers. So redundancy. You don't want any single instrument or treatment step to be the only safeguard. And so you need backup sensors and multiple barriers to ensure that one failure doesn't become a public health event. And then finally, finished water monitoring. That is an independent check before water reaches the consumers. Next slide, please. So in sum, direct potable reuse, it lacks the buffering and response time that's provided in indirect potable reuse, making real-time detection essential. So that's where a lot of the opportunity lies, is developing those technologies for real-time verification and operational frameworks. A lot of these technologies exist today, but there's a lot of barriers. So capital cost for sensors, you need the technical expertise to monitor those sensors, the workforce, and operation and maintenance. So in sum, it's a really exciting time for the water sector, and there's a lot of innovation going on and different technologies from different industries being adapted for reuse. So next slide, please. So I want to thank our partners, our consultants who have supported us, and our research funding partners, including the Water Research Foundation and Metropolitan Water District. And that ends the presentation. Thank you very much.
Thank you. Michael, I'd invite you to stay on camera, and Suzanne, if you could come back on camera, we have a few questions. So the first, see if I can pull it up here. Okay, it's about water quality sensors. So the question is, while using the quality sensors, I have come across the formation of biofilms at the sensor's touching points, where it leads to false data. Have you come across such things, and do you have any advice on how to prevent or mitigate those biofilms?
I don't know, Michael, if you have any. I responded to the chat while you were talking, so, but I don't know if you have any in addition.
I do not. I do know that there, for certain samples, there's different protocols that are required. And so you need to sanitize the surrounding areas of the pipe or the collection sample point before collecting the sample. That's a little bit different than what you were describing.
Yeah.
Yeah, no, I don't think I have anything more to add to that.
Yeah, the only thing I said is that they're getting better. And at this point, I think the challenge is that a lot of this stuff is still going to be expensive, especially if you're doing it on a larger scale. So material selection, the type of sensor is critical. The biofilm definitely likes different some materials versus others, so consideration of that when you're making these decisions. And then the cleaning and the protocols that you do for that is critical. And then, you know, if you're seeing consistent results based on the biofilm, then there might be an ability to do some correction with that information, but you would need to develop some consistency in the results you're getting if you're not able to do it with those other methods. So it is a challenge, and we're going to all have to face it on some of these sensors as they're getting better and better.
Yeah, and I see, Jorge, you have your hand raised, but if you could put your comment or question in the chat, I'm not sure that you'll be able to take yourself off mute in this format. Okay, so the next question is there an opportunity to predict influent water supply to optimize advanced purification treatment operations and permitting requirements?
I can share something that I saw recently at the Water Reuse National Conference. There was a company called Cando, and they develop real-time monitoring for the collection system. And so they have a variety of sensors, conductivity or temperature, pH, that if they go out of range, it will give a alert to the operators. And then at the same time, they have an auto sampler that will collect a sample at that time. And then they can go and analyze that sample in the laboratory and see what the nature of that event was. And so that gives operators an advance warning of what's coming to their into their treatment system. And then besides that, you know, for DPR and IPR, it's really important to characterize your source water, and that can help inform your treatment barriers that you implement. However, there are limitations with that because there's only so much that we can detect. It gets very expensive, and there are certain compounds that we don't even know to look for. And so for direct potable reuse, the way that it's regulated is that we have multiple barriers. And I went through those different mechanisms and treatment processes, and that's supposed to account for all of the unknown unknowns that we don't even know is in our water.
Yeah, great, thank you. So the next question has to do with public outreach. And Suzanne, this is for you. How has the local and youth population received the project so far?
Yeah, I mean, well received so far. I think it helped a lot that they've already have some successful projects behind them that the community really does love. Our biggest challenge is getting the community to understand the differences between the two. So from a water quality perspective, we're walking that line of this is cleaner, better quality water, but the water that's, the reclaimed water that's going into the existing wetlands is perfectly fine, right? So from a public education side, we have to really sell both and help them understand the differences. This is going to be a park versus a boardwalk. Because we're treating to this higher quality water, they will be able to kayak on it. Like, we have some more connectivity. They're not separated by the boardwalk. There's trail systems. So we're not like throwing it in their face, but we are trying to make them understand the differences without making either one better or worse than the other. So I would say from a community perspective, the buy-in is there, but the challenge is really, what is the difference in not making the other one look bad from a child perspective or the community school system and things like that. They are actually scheduled to do the school district has bought into this and is scheduling all second graders in the whole county to go through this education facility as part of their second grade program, which is really focused on water supply. And so we did have to really look at the exhibits and make sure that things like explaining what a RO and UV does are very adjusted to explaining that to that age. So that has been the biggest challenge of that. But I think, the use of characters and fun and things like that has made it work well. We will see when we open up at the end of the year. So thanks for the question.
That's great. Yeah, I was going to ask how many people you expected to reach through the educational center, but all second graders in the county, that's quite a lot of people.
Yep.
And is that educational center, is it geared K through 12 or is it meant to be even broader than that?
I mean, the community that we have in this area is actually interesting. It's a retired community or close to retirement community, right? And so we actually had to make it so it works for second graders and that level. So it's hopefully it has a little bit for everyone. It's kind of like, I think we have 15 exhibits. So I would picture like going to a museum and you're automatically attracted to one thing, right? We'll probably see that, we'll see a little bit of variety in what people are attracted to from an exhibit perspective, but we put in enough that gives them, everybody something for everyone.
Something for everyone. Yeah,
Yeah.
That's great. All right, this next question is from Henry. He says, my experience as startup and operation of potable reuse systems is that there's generally a lack of system integration due to the differing performance profiles of individual unit operations. What is a good way to address this during the design phase of a reuse project? So Suzanne, this might be a good one for you since you're in construction and have completed the design.
Yeah, and I would completely agree that, and that's at every project really that has multiple treatment systems that really can operate in separate and parallel. Our UFRO is coupled. So that does help it a little bit in the fact that they do need to be commissioned as a unit. So it narrows us down to about really 2 systems. But it is a challenge. And I think one of the things that we've done and that part of that workflow that you saw on the commissioning side is connecting those dots early and making our commissioning plan really connected to the design intent. And so we, just like you normally do on everything, every system has to be checked out by themselves because they obviously have requirements, but giving time for the connectivity between the whole system and the design and making sure that it's producing the intent, not just the individual component. And because we have breakpoint chlorination and a couple of other unique things, it's extra important to do that. So I completely agree that that's probably the biggest challenge. And I think more than anything, it's, do you have enough time to do that well? And the commitment by the staff to do it. And maybe it's because we're a progressive design build that it helps that cause because our design team is pushing that effort versus in a normal setup, if it's not required in the spec, then they're not going to do it type of thing. So I completely agree. And I think that reuse projects is really important. It should be something that people consider when they're either writing the specs or when they're working with their teams to make sure there's enough time to do that well.
That's great. Yeah, and that could go down a whole nother interesting conversation as the delivery method for these types of projects and which might be the best. So great. So the next 2 questions are for you, Michael. The first is an economic evaluation being conducted simultaneously with water monitoring using software?
We are not currently doing economic modeling or evaluation. We're really focusing on the treatment processes and treatment trains themselves and those technologies and trying to see which treatment trains and technologies are the most effective and how the different sequencing of those technologies impacts the water quality. We are thinking about the economics of this. So, for example, for the ozone BAC process, that sequence gives a little bit less flexibility because your treatment process is either going to be all DPR and it doesn't give you the ability to do some IPR and then some DPR. And so we're doing that post our reverse osmosis treatment trains with the idea that we treat all the water to an IPR standard and then we have a side stream for DPR. So we're thinking big picture economics. We're not currently doing, like smaller economic evaluations.
Yeah, that makes sense. And I guess just visioning this project over the next, say, 5 years, where do you see it going, and how do you see the economic analysis kind of playing in over time?
Yeah, so the demonstration facility that we are going to be constructing in the next 5 years or so, that will be looking more at the economics for the future full-scale implementation.
Yeah,
And I'll give you one example of someone who is doing that economic evaluation. Again, from the water reuse conference that I went to, there was a Orange County Water District. They're doing a digital twin, and that is tied up into their economic model. And they demonstrated how they're able to reduce the energy requirements and using machine learning to reduce the energy requirements of their processes.
Oh, wow. That's a great application of a digital twin. Okay, and then next question for you, Michael, still. You mentioned fusion models as an end goal for DPR digital. Have you thought through the best use cases for fusion models as it related to DPR projects?
Yeah, so I would say that artificial intelligence, machine learning, has a great application. That digital twin model that I just discussed, it really can help to reduce the operational burden and maintenance burden. Working with some of the wastewater treatment plants, we hear about some of the issues that they face, even with the treatment, even with the lower level of sensors and instruments that they have to deal with. They struggle finding the technological expertise and hiring enough staff to monitor and maintain those. For DPR, that problem is multiplied or even exponential, just based on the number of sensors that we require to have at these facilities. And so we need to find ways to make that easier. And using a digital twin, using artificial intelligence, machine learning, those are ways that we can help to make everyone's life easier. And automating more of the treatment decisions, diverting water if it's unsafe, automatically, critical control points. I would say those are the end goal for these types of projects.
Yeah, that's great. I'm glad you touched on that. I was actually thinking as you were going along if there was, a potential for the use of machine learning and soft sensors maybe as we progress more into IPR and DPR. All right. Well, I think we can get our speakers out of the hot seat. Oh, we got one more. Okay, last question, and then we'll wrap it up. So what are the biggest gaps in current sensor technology for monitoring treated water from DPR?
For treated water, well, the issue is that that water is so clean, and we're not able to detect contaminants at that low level. So I would say that's really one of the challenges for DPR. And so developing new laboratory methods, sensor technologies that are able to detect lower levels of contaminants is one of the ways. But given the challenge of doing that, developing that multi-barrier treatment process that I discussed earlier, we're not going to be able to detect that low level of contaminants. So how do we develop the frameworks and the crediting frameworks in order to ensure that the water is safe to drink?
Yeah, and I think you touched on earlier some of the TOC monitoring, I think, can be a challenge in terms of validation of TOC as well.
Yeah.
All right. So Suzanne, any final thoughts before we sign off?
I mean, I would just add, and this is, I guess, probably already was stated a little bit, but the real time versus that stuff that needs to go to a lab, and trying to I completely agree that the labs now can't even handle the stuff that the detection limits that we're requiring, but what needs to go, what doesn't need to go, and really creating a strategy that allows multiple levels of data and what, the defense of that data and the protocols for those data, so that you can utilize some of it for certain purposes and others that are standard practices have to go through a standard process. So really just maybe rethinking how that whole system works to support these projects, I think, is something that would be beneficial.
Yeah, great. All right, well, we've come to the top of our hour. Thank you to our speakers. Thank you for the great questions that came through the chat. And thank you to Maddie and the SWAN staff for setting this up. So take care, everyone. Thank you.
Thank you.
Thanks, everyone.